right, in Canadian dollars. And so we want to see if having this online chat feature is profitable for the company. The best way to do that is to run a correlation analysis and also run a regression analysis, which we will do in chapter 5, same data set. So I have started the scatter plot showing the 5 customers, each point. So the very first point corresponds to the first XY pair. So we have 20 minutes for time spent corresponds to 85 Canadian dollars. The second point on the scatter plot is 50. So that customer spent 55 minutes and then went on to spend $110. Third customer spent 105 minutes on the chat feature and ended up spending $130. The fourth customer ended up spending 85 minutes and then went on to spend $117. And finally, the fifth customer spent 45 minutes and then went on to spend $95. So looking at this, and it's just a sketch, but we can kind of get a visual idea. Do we have an association between time spent on the chat feature and sales? Yes. Well, how would you describe it? Yes. Yeah, it's only 5 points, but we can see that it is 10. It looks like a strong association, a strong correlation. And would we say positive or negative? Yeah, positive. Right, positive. So as the time increases, the sales also increase, right? Positive. So it's a positive, and we will know for sure by actually calculating the value R, the correlation R, which we're going to do. So what we need to do is get the mean of time, the mean time, which is the average. And we all know how to do that. We take 20, add it to 55, add it to 105, add it to 85, add it to 45, and divide by the total. So if you can all get your calculators, we can do that. And we also want to do the same thing for Y, the sales. So we want to sum them and divide by 5. In this case, our N equals 5. 5 customers. So what's the average number of minutes spent on the chat feature? As soon as we get those, we add those 5 up. Always have your calculator ready because we do quite a bit of calculation in these, especially these chapters 4 and 5. It's always a good idea to have it ready for quick calculations. Okay, anybody? You have it? The average minutes? Yes? 62. Exactly, 62. 62 minutes. I'll just put it in brackets there. It'll be minutes. And what about the average for the sales, the Y? Again, we want to sum all of the sales. 85 plus 110 plus 130 plus 117 plus 95. Divide by N, which is 5. We get, yes? Yes, 107.4. So that would be $107.40 is our average. Okay, and from there we can calculate the correlation, but we need two more quantities. We need to calculate the standard deviation of the x, but we'll start with the variance of the x. And so for every point in the data set there, I'm just going to try and show both here. We want to take the value, so the first time spent is 20 minutes, and we subtract the average, and we square it. We do that for the next one, that would be 55. Subtract the average, which is 62 minutes, and square. Don't forget to square these. Then we want to do the same thing for the next one, which is 105. Subtract 62, square. Plus 85, subtract 62 and square. And finally 45, subtract 62 and square. And all that gets divided by 5 minus 1. So I'm just going to do an equals there. We can break this down. If you want, you can break it down. So that would be negative 42. And I'm going to keep it in brackets because it has a negative and we're adding. The next one would be negative 7. And the next one should be positive. So that's going to be 43 because it's, 43. And the next one is going to be $85, subtract 62 is going to be 23. And finally, we have 45. 45, subtract 62, it too will be negative. So I put it in brackets if it's negative. Divide by 4. And you should have a variance here. If you work that all out. Give you a moment to work all that out. It ends up being 1120. But we're not done yet because we want to get the standard deviation. So to get that, we need to take the square root of that, which is going to be 33.4664. And then we have to do the same thing, exactly the same thing with the sales. I'm just going to give myself some room, make sure we have lots of room here. We do. So we'll do the same thing with sales. That would be subscript Y. We use subscripts to denote whether it's the explanatory variable X or the response variable Y. So it's going to be 85, subtract 107.2 or 0.4 rather, squared. And the next one is 110 minutes. I'm going to try to squeeze these in so I don't lose room. And 117. And one more to go is 95. And that's squared. Hope we can see that on the screen. That is squared, the last one. And we divide it by 5 minus 1. And then we can get those squares. That first one will be negative 22.4. 110, subtract 107.4. I get 2.6. 2.6. Let me make sure that's clear. Ugh. Squared. Add that to the next one, which is 130. Plus 117. So 117 subtract 107.4 is 9.6. And try not to be a picture taker. Try to write these out. You'll remember how to do the process better. That will be negative 12.4. You get so much more from it if you're writing these out. And that gives us 316.3. And then the standard deviation is the square root of that. And I'll leave this up for a moment for you to get caught up if you need to. So the square root, I end up getting 17.78482. And you might be wondering, why am I keeping all of those decimals? And it's because it's going into another formula, the correlation formula. And if I don't keep those decimal places, I'm going to really compound the error. It's the rounding error. It's going to have a lot of rounding error. So we carry as many decimals as possible until the very final answer, which will be the correlation. Okay? So good to carry 4 or 5 decimals if you can. It's not too hard. And then we get the correlation. So I'm going to keep going here, and we'll start with the correlation. I'll bring this down a bit more so we can see the correlation. Hope you can still see that. Is everyone okay with this sheet? Okay. So those are the 2 values we need, and we're going to compute now the correlation R, which is going to take each value, 20, and we're going to subtract the mean, but this time we don't use any squares. We just take the first x, subtract its mean, and the first y and subtract its mean. And we do this for each pair. The next pair will be 35. There's lots here. We're going to have next 110. This is the process we use to calculate R. The next one will be 105. Is that the next one? Let me see. Yeah, 105. Multiplied by the next one will be 130. 107.4. I'm running out of space, so I'm just going to keep going here underneath. That's going to be 85. Multiplied by 112. And finally, we're going to have the last pair, which will be 45. Subtract 62, multiplied by 95. Subtract 107.4. We're going to divide all that by 4. I'm putting brackets around them because we're multiplying these, times, we want the standard deviation from up there, which is 33.4664. We just calculated that. And the standard deviation for the y, which we just calculated as 17.785. 0.9482. So take care putting all of these in. You can condense them down to, 20 subtract 62, what that would be times the next one. You can keep simplifying it. We would then get negative 42 times negative 22.4 and so forth. Okay. Or you can put it all into the calculator at once, all the numerator, and then equals and divide by 4 times 33.4664 times 17.78482. So to check your work, the numerator should come out to be 2326, and the denominator is 2380.776. That's what you should get. So the numerator, if you do the numerator first, just multiply and then add, and then multiply and then add. So we're taking each pair, right? Each x, subtracting its mean, and each y and subtracting its mean, and multiplying them and then adding them together for the numerator. And then the denominator is n minus 1, which is 4, times the standard deviation of the x times the standard deviation of the y. Question? Which one is that? Yeah, 55. Thank you. Good catch. Yeah, 55. I was trying to read it from another screen. Yep. Yeah, so 55 was the second X, right? Customer number 2. Yeah, so customer number 2 spent 55 minutes. Any other corrections that you see? So we're not done yet. We need to divide. We need to get the actual number, and we end up getting 0.976992. So therefore, the correlation is equal to approximately 0.98 with the larger data set. Okay, so if there's no questions, we'll keep going. There it is right there. And it says here, finally, would the correlation R change in writing there? Would the correlation R change if the amount of time spent was in hours instead of minutes? No. Perfect, yes. Correlation R has no units because we have minutes in the top, right? Minutes, we have minutes and sales in the numerator, minutes and sales in the denominator, and they all cancel each other out. Minutes divided by minutes will be no minutes. Sales divided by sales will be no sales. So R is a unitless measure. So, and it doesn't matter if you change those units, it still will be exactly the same. So we could convert all the data to hours and it would still give us R equals approximately 0.98.